Lovely smoker voice today. Okay, so rational functions have to be functions that are written as a fraction. Okay, that fraction, we use f of x to represent a function. It's going to be p of x over q of x. Okay, that might look a little foreign, but p of x represents a polynomial, and q of x represents another polynomial. Okay, so p of x and q of x are polynomials. Okay, and when we have a fraction with q of x in the denominator, we know that q of x can't equal what? Well, it could equal p of x, because that would be 1. P of x divided by p of x would be 1. Right, why can't q of x equal 0? Right, we're not allowed to divide by 0, right? What's it called when you divide by 0 and get an error? Huh? Really close, not undetermined, but undefined. Okay? You can't divide by 0. So the polynomial in the denominator can't be 0. Okay. So, we've talked about the denominator not being 0 before when we were finding excluded values. So we're doing a similar thing today by finding points of discontinuity. Points of discontinuity. Everyone say that word, discontinuity. Yeah, try it again. Discontinuity. Discontinuity. Try it again. Tyler, try it again. That's good. Good job. Okay, we have two different types of points of discontinuity. And what does discontinuity mean? Any ideas? Yeah, discontinuous. So the opposite of discontinuous would be? Okay, what's the opposite of being discontinuous? What? There we go, continuous. That's what we're looking at today, okay? I'm going to draw a picture, you don't have to draw this, okay? Because I'm going to erase it. Okay, we have a pencil rule. A function is continuous. Man, I sound terrible, I'm sorry. A function is continuous if you can follow the function with your pencil and never pick up your pencil. Okay, that's continuous. But sometimes we have little holes in the middle. Sometimes we have holes. And this would be not continuous, because if I follow my pencil on the graph, I'm going along and I go down, 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 but to get to the other half of the graph I have to jump, pick my pencil up, and then continue with the graph. So that would be not continuous. Another one that would be have a discontinuity would just be something like this, that there's just a missing piece right there. Okay, if there's a hole in the graph, or you learned last time a word that starts with an A, where we could have, gets closer and closer to this line. It was on the video with the substitute. Asymptote. Okay. Those are areas where you get points of discontinuity, okay? So if you can keep your pencil on it the whole time, it's continuous. If your pencil has to lift off the paper and restart, then it's not continuous. There's a discontinuity. Okay, there's two different kinds of discontinuities though. For example, one, we're going to look at a removable discontinuity. Removable discontinuity. Okay, so our example will be y equals x plus 3 times x plus 2 divided by x plus 2. X plus 3 times x plus 2 divided by x plus 2. Okay, so remember we said rationals are anything that can be written as a fraction. Is that a fraction? Yeah. Yep. And we also said the numerator would be a polynomial and the denominator would be a polynomial. Is the numerator a polynomial? Yeah. Yeah, we have a binomial times a binomial. If you times those together, you would have a trinomial. So yes, it's a polynomial. And the denominator is a binomial. Okay, there's one thing missing though, that the book didn't print, and I didn't write down, but when we practiced for our test last time, it should become a habit to always do what? What are we missing? Styles? No. These are already factors. We're missing something though. Parentheses around binomials. I want you to make that a habit. When you see a binomial, throw in parentheses, okay? So this is similar to the test and similar to our startup that we did today. What would you have done on the test if you saw a problem like this? It's already factored. Those parentheses binomials are factors. Cross out the matches, right? X plus 2 and x plus 2. Good. So we get y equals x plus 3, which is linear, right? X plus 3 is linear, because x to the first power would be a linear function. But we do have an excluded value. X cannot equal what number? Yeah, -2, because that would make the denominator 0 in the original, right? Okay? This is, if you don't have a calculator, hurry and come up and get a calculator, because I'd like everyone to graph these. Take a look at them. Excuse me. Okay, go to y equals on your calculator. Clear out anything that was in there. And we're going to type in the original. Now, the original function before we I'm so sorry. Before we canceled out, had 2 binomials in the numerator, right? So we need to put double parentheses so that we're showing the calculator both of these belong in the numerator. Okay, so do double parentheses. X plus 3, close the parentheses. So x plus 3 is enclosed in its own parenthesis, and then x plus 2 will be enclosed in its own parenthesis as well, and then make sure you end with a double parenthesis. That double parenthesis is just grouping both of those together. Does that make sense?
You don't have to put parentheses in those two?
No, if you just put 2 parentheses right next to each other, that means times.
Oh, okay.
Yeah. Okay? And then divide by, make sure that binomial is in parentheses. Parentheses x plus 2. Okay, now what happens if your window's messed up? How could you fix that? Go to Zoom Standard, okay? In case your window's messed up. Go to Zoom, it's number 6, I believe. Okay, so if we graph it, we said that there's an excluded value at -2. But look at the graph. At -2, does the graph go through -2? Is there a point at -2, or is there a hole? I don't think so. If you look at -2, I can see that the line goes straight through. Because this is called a removable discontinuity, right? Okay? It's removable because we're able to cancel it out. Okay, so if it cancels, that's a removable discontinuity. Okay, so we have a removable discontinuity at x equals -2. I'm sorry, there's a question? And the next one will be non-removable. So if it cancels out, that would be a removable one, because we can take it out of the picture. Okay? The next one, though, is going to be a non-removable. So for example, 2, we're going to show a non-removable discontinuity. Okay, example 2 is y equals x plus 4 divided by x plus 2. What's the habit you should have developed that we should throw in right here? Parentheses in 2 different places, right? Here and here. Okay, Okay, do those cancel out? Okay, well, I have a question for you. Everyone put your eyes up here, please. I see I have two x's. Am I allowed to just cancel those out and then I get 4 divided by 2, which is 1/2?
No.
Well, lots of people do that on their test. So explain to me why I'm not allowed to do that. Okay. Well, what's the rule? Oh, there it is, Paula. You can only cancel if the neighbors are being multiplied. Is x's neighbor being multiplied? No, it's being added and added. Okay, so that's not allowed, so please don't do that on your future tests or your homework, okay? These do not cancel at all because of the addition. Okay, but we do have an excluded value. X can't equal what number? -2. Since it did not cancel out, that's called a non-removable discontinuity. Non-removable discontinuity at x equals -2.
I have a question.
Yeah.
How do you know it's
Okay, because the denominator can't be 0. So what number plus 2 would be 0?
-2?
-2 plus 2.
Oh, so what you're trying to do is make it equal 0?
Right.
Okay.
Because it would be undefined if the denominator was 0. What?
And that would be with x equal.
Right. Okay, yep. And when it's just a binomial like this with 1x, then you really just think, oh, what's the opposite sign, right? If it says plus 2, it would be -2. Okay. All right, let's grab our calculators and graph this and see why this one's not removable. Okay, go to y equals, clear out the old stuff. Make sure your binomials are in parentheses. Okay, x plus 4 in parentheses. X plus 4 divided by parentheses x plus 2. Right? If we graph it, what happens at -2? There's nothing there because at -2 the graph is going down, 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 and then we have to lift our pencil up in order to continue with the rest of the graph. Right here at -2 there's actually an asymptote because we're getting closer and closer and closer to -2, but it's never going to hit -2 because at -2 it would be undefined. Okay, so that word from the notes last time, asymptote is what we get right here, which is actually what we're going to move to next, is finding the asymptotes by just looking at the equation. Okay, so the difference is about the discontinuity. It's removable when it cancels, right? If it doesn't cancel, then it's non-removable. Does that make sense, the difference? Okay, now we're going to talk about asymptotes. ASYMPTOTES. Everyone say that word, and if you say it fast, it doesn't sound like you're swearing. Asymptotes. Say it. Asymptotes. So we have totes. Totes. Yeah, not just toe. Totes. Okay, so we have two large words today, discontinuity and asymptotes. Okay. Starting with a vertical asymptote. Okay, a vertical asymptote excuse me, is easier to see based off of the equation than a horizontal asymptote. Horizontal is really not that bad, it's just there's a bunch of different scenarios that could pop up. So, for example, 3, f of x equals p of x over q of x. We get vertical asymptotes when the denominator is what number? So what's the denominator not allowed to be, guys? 0. That's when we get a vertical asymptote. Okay, so we get a vertical asymptote, when q of x equals 0. Okay? So let's look at an example and see if And you don't even have to graph it to see the vertical asymptote. You should just be able to look at the equation. Y equals x minus 2 over x minus 1 times x plus 3. Y equals x minus 2 all over x minus 1 times x plus 3. Okay, what do I need to do on the numerator? Parentheses. I've emphasized that a lot, and I hope it's becoming a habit for you guys. Okay? Do we have any removable discontinuities because we have a cancel? No. Okay, but what are the discontinuities? And our excluded values. X can't equal what? Let's try this. Ariana, what about this one? What can x not equal?
1.
Good. And what about this one? Perfect. Right? So what type of discontinuities are both of these? Non-removable because they didn't cancel out. Right? Okay, let's look at the graph and see what it looks like. Okay, go to your calculator, go to y equals, clear it out. Now it's the denominator that needs the double parentheses because we have two binomials in the denominator. Okay, so in the numerator, everyone's on y equals? Okay, put parentheses, x minus 2. Close the parentheses, divided by. Now we need a double parenthesis because our numerator has two pieces, or our denominator has two pieces. Double parenthesis. So our calculator knows both of these are in the denominator. X minus 1, close the parentheses, times parentheses, x plus 3. Make sure you end with a double parenthesis. Okay, so we hit graph. What happens? Something weird, okay? Can you describe what happens? Besides the phrase something weird. It splits, okay? That's the way to say it. It splits right here at which number? -3, and right here at which number? 1. Weren't those our excluded values? Yeah, so what has happened is it's created a vertical asymptote. Because right here, it goes down, down, down forever. It's getting closer and closer to -3, but it will never reach it. Okay, and right here, it goes up, up, up. Tries to get closer and closer to -3, but it will never reach it. Same with +1. Okay, so the denominator, when it is factored, it shows you the vertical asymptotes. So we have a VA, vertical asymptote, at, okay, remember asymptotes should be an equation. So a vertical asymptote goes up and down. If we were to draw a line up and down, what axis are we slicing through? No, y-axis, you have to slice that way. X-axis, if you're going down, that's slice through the x, right? So x equals 1, and at x equals -3. We have two vertical asymptotes. VA, vertical asymptote.
So that will be our answer for like all of them.
If it asks for the vertical asymptote, then yeah.
And then we have to like identify if the non-removable is removable and whatever.
If it asks for it. The first problem on the homework asks you to do like all 4 different things at the same time, and then all the other problems on the homework just ask you to do like one thing. So just whatever is requested.
I'm not getting the same graph as we.
You're going to do a double parenthesis. I think it's your window, okay? Go to zoom and go to standard number 6. Yeah. It's still slightly different. X minus 2 divided by x minus 1. Oh, we did +3. That's the difference. But now it should work. Okay? Okay. Okay, let's do another quick vertical asymptote. Example 4. Y equals x minus 2 over x minus 2 times x plus 3. Y equals x minus 2 over x minus 2 times x plus 3. Ah, there's a cancel, isn't there? This is, what type of discontinuity do we have right here? Removable discontinuity. Okay? So there's only one non-removable. And if, we're starting to run short on time, so we're not going to graph this. But if we graph this, you would notice the only place we actually have a vertical asymptote is at the non-removable. So what would the vertical asymptote be for x plus 3? At -3. So vertical asymptote is only going to happen at the non-removable. Okay, so we have a VA at x equals -3. And remember, it is an equation, so you need to have an equal sign. Okay, next we're going to do a horizontal asymptote. Horizontal asymptote comes in 3 different situations. Okay, example, are we on 5? Yeah. Alright, now this is going to sound a little silly, but you guys know where Mexico is?
Yes.
No, you don't?
I forgot.
Do you know where Nicaragua is?
Yes.
Where's Nicaragua in relationship to Mexico? Underneath or south, right? Okay, keep that in mind. Okay? Because our function f of x, whatever x is on the numerator, it has an exponent. We're going to label that exponent m for Mexico. Okay? And the denominator x to the n for Nicaragua. So Mexico's north, Nicaragua's south, right? Same in real life. Mexico's north, Nicaragua's south. Okay. There are 3 situations for the horizontal asymptote. It could be, let's see, where's my first one? Excuse me. X, we have y equals x plus 1 over x minus 3. Okay. So what is the value of the numerator's highest power? X to the 1. So that means m is 1. What about the denominator's highest power? 1. Okay, so our first scenario is when m equals n. Okay? Because 1 equals 1. Right? And the powers are exactly the same. When the powers are exactly the same, equal the horizontal asymptote. Actually, I'm going to squeeze in a number here. It's probably better to give you more in-depth examples. So let's put a 3 here and a 9 there. Okay. When the powers are exactly the same, then the horizontal asymptote is, and when we're horizontal, which axis are we slicing through? We're horizontal. The y-axis. Good. So it's the equation y equals the leading coefficients. Okay? 3/9 would be the same thing as 1/3. Okay, so the horizontal asymptote would be the leading coefficients simplified, the simplified fraction of the leading coefficients, when their powers, numerator, and denominator are exactly the same. Okay, the next example is when they're not the same. If they're not the same, what could happen? They're not the same, then one would have to be bigger, right? Okay, so for instance, we could have the numerator be bigger, like 4x cubed minus 2 over x plus 8. Okay, what is the highest power of Mexico? That's the numerator. 3. What's the highest power of Nicaragua, which is south, the denominator? 1. Okay, so in this case, is Mexico's power greater or smaller than Nicaragua's? Greater. So when m is greater than n, okay, when m is greater than n, there is no horizontal asymptote. The horizontal asymptote, or the HA, is none. Okay, when they're equal, it'd be the fraction of their leading coefficients. But when Mexico, the numerator, is greater than Nicaragua, the denominator's power, then there is no horizontal asymptote. Yeah?
What was HA stand for?
Horizontal asymptote. Yeah, we use VA for vertical asymptote and HA for horizontal asymptote. And the last scenario would be, which one am I missing? I've done when they're equal, I've done when Mexico is greater than Nicaragua. Nicaragua is greater than Mexico. So, y equals x over 7x squared minus 2. Okay, shout it out. What's the power of the numerator? Mexico. 1. Good. What's the power of the denominator? Nicaragua. Good. So here, Mexico is less than Nicaragua, right? Okay, so 1 is less than 2. When this happens, okay, when your denominator's power is larger than your numerator's power, then the horizontal asymptote is always the x-axis. And what's the height if you're at the x-axis? 0, right? So y equals 0, or the x-axis always. Okay, so you can just look at the equation to find the asymptotes. Again, there's 3 scenarios. If the powers are equal, that's when you get a different horizontal asymptote. Okay, that's when you just take the leading coefficients. If the numerator is larger, there's no horizontal asymptote. If the denominator's power is larger, there is a horizontal asymptote, but it's on the x-axis always. Okay. So your assignment begins on page 387, but my paper fell out. Let's see, yep, 387. Numbers 2 through 24 even. So how many problems is that? 12.